Wang Di from Whamcloud, ladies and gentlemen.
Okay, I'm Di from Whamcloud, and this is the first time I speak English in front of so many people. I'm probably very nervous, so if I say something stupid, please bear with me.
You're doing great.
Thanks. So I will talk about the DNE Phase I today, and this project is funded by OpenSFS, and the goal of this project is to the goal of this project is to have multiple metadata targets, so the file system can be distributed over several servers. And the whole project is divided in two phases. The phase one is a remote directory. The phase two is strap directories. And for the remote directory, the subdirectory can be created on a different MDT with the parent. So you can see the picture. The root is on the MDT 0, but the Frank and Rose is on a different MDT by a special LFS command. And also on phase one, since you have multiple metadata targets, so you can distribute the namespace over several servers as OSS does today. And also you can group the metadata server and assign them to the different jobs and users for different purposes. And since all the MDT are in the same file system, so the files on any MDT can use all the OST, so they can use the bandwidth from all of the OST. In the phase one, the remote directory can only be created by the administrator only, and by the LFS command. You can see that command. -I will indicate which MDT the directory will be located. And compared with the single MDT operation, as this create remote directory is a little bit complicated. It needs RPC between the MDT target. It needs the disk synchronized on the server side. So I will explain that later. And but for the other operation, it's totally local. It means that if you create files and subdirectories and the remote directory, these files and subdirectory will stay in the same MDT with the remote directory. And so for the local operation, there's no performance impact. And but there's a few limitations here. You need to be careful. And the first one, we don't do duplication right now. So if one MDT failed or the administrator disabled the MDT, you will lose all the namespace and subtrees on that MDT. And if the MDT 0 is failed, so you lose all the file system. And then the remote directory can only be created on MDT 0. It means that the parent of the remote directory must be in the MDT 0. And why we do this? Because if you look up a file on any MDT, you can walk through the MDT only the MDT 0 and the MDT where the file is located. So then there's no other MDT between them. So if one MDT failed, you only lose the subtree on that MDT. There's no other MDT being affected. So clearly it's a policy decision. And we probably will add a tunable proc entry. You can enable to do that on other MDT. But you need to beware of the risk to do that. And then the rename and link cross MDT is not supported on the phase one. And if you try to do that, you probably will get an EX style error. And these restriction and limitation actually help us to implement the DNE quickly, so we can deploy them quickly, so then we can gain some experience. Then this limit will probably be removed in the later version of DNE. Then how to enable the DNE and or upgrade DNE from your existing file system. First, you need to make sure that First, you need to make sure that the disk format has the data feature, which is default if you reformat your file system after 2.0. But for 1.8 file system, you probably need the command show there. It's tune fs -o dir data. This is necessary for you to create the remote directory because you need to put the feed on that entry and point to another MDT. Then you need to upgrade the file system to 2.4 all the node. So then, and also you might need to erase the config log because the config log of non-DNE and DNE probably will be incompatible. And of course, well, it doesn't mean that you have to enable DNE after you upgrade to system to 2.4. I'm sorry, I didn't see that as DNE as the target release for the remote directory is 2.4. But once you enable DNE and use that, and you you are not satisfied with that, you want to disable that, it probably take a little bit more efforts because you need move the files and directories on other MDT back to MDT0, then disable those MDT, then go back. It's doable, but it's probably needs some efforts. And we also support the online adding new MDT. But the clients must to understand DNE. If they don't understand DNE, they will be evicted. It means that you need to upgrade the client to 2.4 as well. And adding the new MDT, the command is quite easy. It's just make fs and then mount. And don't forget to indicate where is the MGS node. Then on the phase 2, we will implement the strap directory. So the directory can be stripped to multiple MDT. So the big directory's performance will be improved. And also, we probably will allow the cross MDT rename and link on phase 2. Next, I will talk about how DNE is implemented in phase 1, but before that, there's a little background information, feed. As you know, the feed is brought into the Lustre 2.0, and before 2.0 in 1.8 or 1.6, we use MDS number to identify file directories on the over the file system. But when you have multiple MDT, you cannot do that anymore. So we use feed to identify object to over the cluster, and the feed has 3 components: the sequence, OID, and version. The seq is 64 bits, and OID and version are 32 bits. Currently, only the seq and OID are being used. The version is just 0 right now, and there's each sequence have 128,000 objects. So there's one sequence controller over the whole file system, and so initially when each target starts, it will request a big range of sequence from the sequence controller. The sequence controller is on MDT0. So each target will request a big range of sequence from the feed controller, and this is very big. Actually, it's 1 billion sequence. So if the client wants to create the file or directories, it will request a feed from this target. And of course, for efficiency, you first you just request a sequence of feed. You don't need to go to MDT every time. You don't go to the server every time to get the feed when you create the file. Then there's also a feed location database to tell you where the server is. So if the client wants to do something, you need to check the FFDB first to know where the feed is located, where the object is located. And since each target just got a very big range of sequence, so the FFDB is actually very short. So it's probably about the entry count is equal to the MDT count or plus OST count right now. And also there's an object index table on each server, actually on each target. So on the server side, when they get the request, they can get the real inode from the feed. Then DNE. Okay. The client always knows where the root is. It's in the MDT0. So it always starts from the MDT0 to do the path name lookup. And for most operation, it will send the request to the master MDT, where the master MDT is where the parent is located. For example, if you want to create a directory or create a remote directory, you just send a request to the parent, to the MDT where parent is located. And the client knows where the master MDT by checking the FFDB. So if the operation only involves one MDT, it means it's the local operation for that MDT. It's the same as current single MDT operation. But if the operation involves two MDT, then you need to send the request to master MDT first. The master MDT will distribute the operation to other MDT. Then finish all of them. Then master MDT send reply to the client. In phase 1, there's only two cross MDT operation. It's create remote directory and unlink remote directory. I will explain that later. So this picture is about the create remote directory. So client sends the request with the feed to the master MDT. Then master MDT sends the create object request to the slave MDT. Then slave MDT create object synchronously. And then he return to the master. The master insert the name entry synchronously, then return to the client. So when the client got the reply from the master, since all the operation on the server side is synchronized, so we know that they already committed to disk. So you don't need to, you can just throw away the request right away, and you don't need to care about the replay. Actually, that simplifies things a lot. But still, well, you need to care about the resend. It means that if the master MDT failed during this process, the client will resend the request to the master MDT. And the master MDT will check the XID in the RPC, and they compare that with the one in the last received, and to know whether the object has been done or not. If not, it will redo the operation, and if it did, it just send a reply to the client. Actually, it's basically the same as current single MDT operation resend handling. And if slave MDT fails, and the master MDT will resend the create request, and the slave MDT will check whether this object referred by the feed exists or not. If not, it will recreate that. And the next page is about unlink remote object. Unlink remote directory. It's also synchronized, but there's a slightly different here. So the client sends the unlink request to the master MDT, and the master MDT will delete the entry first, and then at the same time he adds the unlink log locally. Both of them need synchronously. Then he will then there's another thread, log sync thread on the master MDT. It will read these config logs, send the request to the slave MDT, then destroy the object. But this doesn't need to be synchronized because you already deleted the directory from the namespace, so it doesn't matter. And the unlink and the log sync thread will take care of that. And for the recovery, it's also the same. You don't need to care about the replay, but you need to care about the resend. It means if the master MDT fails, the client resend the unlink request to the client resend the unlink request to the master MDT, and master MDT check that check the XID with the last received. If not, he will redo all the operation. And the log sync thread on the master MDT will take care of the object on the slave MDT. It's similar as we do for the orphans for the OST object. Next slide is about how do we store the remote entry on the disk layer, and you can see the feed is stored inside the entry, which point to the object on another MDT. In the graph is MDT1, and on the remote MDT, the object can be found by OI tables by feed through the feed, and each remote entry has a local agent inode. So there's two actual directory has been added to the MDT disk. One is the agent directory, the other one is remote directory. As we each remote entry has since we already said each remote entry will have a local agent inode, which will be stored, and the agent and MDTN depend on which MDT this directory is located. And the object on the remote MDT is stored in the remote directory. So by this way, we can keep the local file system consistency, and also will be helpful to the FLCK crosslink, because each inode under these two directories should have a crosslink from other metadata target. And so when you have multiple MDT, you can do active failover as well, as we do for the OST right now. So multiple MDT can be exported from the same MDS, from the single MDS. So from the graph, you can see that MDS1 take care of MDT1, and MDS2 take care of MDT2 and initially, but if one MDS failed, then the other MDS will take care of that other MDT. So one MDS can take care of two MDT. Next one is little the internal architecture. Actually, is how we implement DNE over Orange branch, and Alex already explained a little bit. I will repeat his words here. And so the top layer is MDT and OUT. So MDT will unpack the request and handle the LDM lock. And next one is MDT layer will analyze the metadata operation. Is actually decompose the metadata operation into the object updates. And for example, if you want you want to create remote directory, then or you want to open create a file, it will decompose to the name entry insert and object create. And the next layer is LOD. It will manage the object updates between the target, so between the MDT OST or MDT MDT. And then the next layer is OSD or OSP. The OSD is local storage device, so it's locally, and the OSP is a proxy, storage proxy for the remote target. So each remote target will have a local proxy device. And for the cross MDT operation, actually, let's, for example, the remote directory. So the client sends the request to the MDT. Then MDT unpacks the request, and he gets the update log from the parent, and MDD will decompose the create operation into the basically two, create and name entry insert. Then LOD will check where these object updates will go, actually by checking the FLDB, and then goes to for the local operation, it goes to the OSD. For the remote operation, for the remote updates, it goes to the OSP. And actually there's two kinds of OSP. One is for the MDT OST, actually one for the data. Another one is for the metadata, it's for between MDT. And then on the for the remote updates, then it sends the updates on the remote MDT, on the slave MDT, and on the slave side, MDT side, the top layer actually is OUT. OUT is called Object Update Target. So since this update has been analyzed, so you don't need MDD anymore, and also these objects updates must be happened in this target, so you don't need LOD either. So just the OUT will talk to the OSD directly to finish the object operation. That's how DNE works. And that's the last page. There's some early test results, and we did that on Hyperion. There's 100 clans. Each clans has 8 mount points, so it's totally 800 mount points. So you can regard it as 8,000 clans, and on each mount point, there's a single thread running on that. And each thread will create its own directory, and under this directory, it will create 10,000 single thread files. And these directories will be distributed evenly over all the MDT. So there's two lines. The blue line is for there's only one MDT per MDS. The green line, there's 2 MDT per MDS. So you can see that with the increasing MDS, you can get the performance improvement linear improvement, and also if you increase the MDT count, even in the same MDS, you can also get the performance improvement. And okay, that's done. Hope you all understand my English.
That was great.
Thanks. Question?